Okay, so week 2, part 2, we're going to talk a little bit about um, types of systems, about energy types and feedback loops. So, we defined a system as interacting parts, and so when we look at the Earth as a system, we have subsystems or other systems working within that. We've got the lithosphere, we have biosphere, the hydrosphere, so all atmosphere, all of these are working together for this larger system. So a system is a group or part that functions together. So we can either have a system that's a closed system or an open system. In an open system, energy and matter move back and forth. In a closed system, everything exists as is. And that's kind of the general definition for that. So in an open system, like as I said, energy and matter can move in and out of the system, and a tree would be a good example of an open system. Trees take in oxygen, take in carbon dioxide, water through the roots, they take in sunlight through the leaves, and they give back oxygen, they give back carbon, detritus to the soil. So things are always moving and in flux. A closed system does not exchange matter. So basically, when we think about the Earth, we think about the Earth as a closed system, that we have everything we're going to have in the system. We have all of the water, all of the gold ore, all of everything. Now, there is talk of mining ice from Mars. Now, whether that's doable, that would certainly change the game plan just a little bit. But we're going to operate on the fact, at least for this, that the Earth as a whole is a closed system. So when we look at systems, we're going to look at, I'm going to see if I can fix that, add to the dictionary. Nope, it's not going to let me. Okay, ignore it. As we look at systems, there's two kind of subtypes of energy. One is endogenic energy, and the other is exogenic energy. So exogenic energy, they might have read it a little bit about in the beginning of the course, but it's energy from the sun, it's solar radiation, and it comes drives rain, wind, storms, and those in part create landforms. They create erosion, they create sand dunes, they can create wind-driven waves that cause erosion or dune buildup on the coast. They cause canyons and valleys. The other form of energy that drives Earth systems is endogenic energy, and this is energy from the Earth's core. And this is what drives tectonics, which causes mountain building, causes earthquakes, also causes valleys. So we have to think about these major processes. So when we are looking at climate, weather, we're going to be talking about exogenic energy. When we talk about sand dunes, fluvial systems and erosion, we'll be looking at exogenic. When we talk about tectonics, volcanoes, earthquakes, that will be more endogenic driven. And then the last concept in this chapter is that all systems have feedbacks, and we're going to talk about feedback loops. And the two loops I want you really to be able to discuss are positive feedback and negative feedback. So positive feedback loop is when a change in a system causes that system to intensify or amplify or enhance, get bigger. A negative feedback system is when that change dampens or stops acceleration. I always thought, kind of on a personal level, sugar is a bit of a positive feedback for me. So the more sugar I have, the more sugar I want, and it can get out of control. And a negative feedback might be at some point I eat too much and I feel sick, and so that could stop that system. So let's look at kind of in terms of geography. So you could look at the population in terms of a positive feedback system. So the more people there are on the Earth, the more people there will be, because people reproduce. And the more people there are, the more people there are. So that's why we have billions of people on the planet right now. So a climate system, you could have a warm atmosphere. So the weather is warm. It melts ice. The ice exposes rock and soil. The rock and soil heats up more than the atmosphere, and that hot or warm rock and soil will actually melt more snow, which exposes more rock and soil, which melts more snow. So you can see a positive feedback system doesn't necessarily mean positive in terms of good or bad. It just means more. Negative feedback system, on the other hand, does not mean bad. It just means stopping a system or resetting the system's natural equilibrium. So let's look at some negative feedback systems in terms of population. You get population increase, more people, resources, not recourses, R-E-S, resources to feed the population are consumed. Oh, it just wants to do that. There we go. You get real-time videotaping here. Resources to feed the population are used up. There's no more. And so less people are fed. You get starvation, maybe disease. So you have less people and the population gets reset. And this is... there are people who believe the natural order of things. The population will actually cancel itself out, and climate change will have its own natural negative feedback to the human causes. Climate, you can have negative feedback. I was thinking about Eastern Oregon, where you have a really nice warm day, temperatures increase, it gets really hot. That heat causes evaporation and cloud formation. The clouds block the solar input and the temperature goes down. So some really big ideas. The solar insolation, the climate seasonality is really important, and the idea of these feedback systems is important as well.